In this video, we shall discuss about speed and velocity. Let me just write it down over here. Speed and velocity. Velocity. And both of them are quite similar to each other. The only difference is while speed is a scalar quantity, velocity is a vector quantity. So we shall just understand each of them simultaneously. Let's get started. Okay, so speed. Now, speed is basically distance covered by an object or by a moving body per unit time. This is what we call distance. So to represent it mathematically, we shall write speed. If we give speed is equal to distance one time, and so its SI unit would be distance would be in meter and time would be in seconds. So its SI unit would be meter per second. Now this was about distance. Now let us talk about velocity. It can also be defined as distance covered by an object per unit time. But there would be some addition specifications that we need to give. Per unit time in single direction. What it means to say is it is just the same as the speed, but we just need to define the direction along with that. So if the velocity if the direction of the object motion of the object changes, then velocity is said to be changed. This formula can be given like this: velocity is equal to distance upon time. Okay, then if we see in the mathematical form, they both are quite similar, or they are almost similar, but its SI unit would also be meter per second. But the difference is, I will explain you with the help of some diagram. Let us say you are at this point and you start moving in this direction and you reach some point B. This is point A. Okay, then you decide to take turn and you reach point C. Okay, then you took some turn over here at some angle, let us call it theta. You took the turn over here and you moved from A to B and B to C. So I will just highlight that path with some color. So A to B, and then you moved from B to C. Okay, then in case of speed, we will consider the total distance as AB plus BC upon total time taken to travel this distance, and you can get the speed. But in case of velocity, you can't say that velocity is this distance traveled upon time taken, because direction is getting changed over here. So we need to account for that. So in case of velocity, direction also plays a critical role. We always need to define the direction along with the magnitude. So what I can basically say is velocity is speed defined along with direction. So I can easily say that let me give some numerical values to this. if distance AB is 5 kilometers and distance BC is 7 kilometers, then total distance would be 7 plus 5, that is 12 kilometers. And suppose time taken to travel this distance is 6 hours, or yeah, 6 hours, then speed would be 2 kilometers per hour. And I can easily say that the speed of the object is 2 kilometers per hour, but in case of velocity I can't say that because here the direction is changing. So what I would have to say is, first I will have to determine this speed for AB, that is 5 upon time taken to travel distance AB, and I will say that for 5 kilometer the object traveled from A to B at some speed, say x, from A to B in a straight path, and then it moved at angle theta from B to C at some speed y. Because when you specify speed and direction both, we actually talk about velocity. So this is the major difference between speed and velocity, and this will as such practically it really does not make much difference. But when you write the definition in your examination paper, the wordings of your answer will really matter a lot. Like if you will say that distance covered by an object per unit time is speed, that's fine. But if you write the same thing for velocity, you will surely lose marks, because and they want you to write the distance covered by an object per unit time in some particular direction is velocity, or you can simply write that velocity is speed defined along with the direction. That would be quite precise definition. So that was all about speed and velocity. Remember, its SI unit and mathematical form is same. So the prime difference is speed is scalar. Speed is scalar, while velocity is vector. Now again I would like to tell you that at this stage in the lower level physics series videos, it is beyond the scope of this level that I can discuss scalar and vectors in details. But if you will refer to the higher level physics videos, you would be able to find the video which clearly explains what exactly is scalar and what exactly is vector. Okay, now let's move on to the next topic, which is the subtopic of speed and velocity, that is uniform speed. Uniform speed, and here it would be uniform velocity. Now what is uniform speed? If an object travels equal distance in equal amount of time, no matter how much small time interval we consider, then it is said to be moving with some uniform speed. Let me explain again with the help of example. This is your starting point, and you move along this path A to B. Now consider that you measure distance at small intervals of time. What I am representing with this blue lines is, here t is equal to 1 hour, this is t is equal to 2 hours, this is t is equal to 3 hours, 4 hours, 5 hours, and so on. Then you took the turn in this direction and you reached point C. Again 6th hour, 7th hour, 8th hour, 9th hour, 10th hour, and finally you reached here at 11th hour. So 6th, 7th, 8th, 9th, 10th, and 11th. Okay, so if we measure distance for first hour, let us say it is x. Then if we measure distance for second hour, that is for distance from this point to this point, if that also comes out to be x. Then for second and third hour, it also comes out to be x, and so on. So if we are able to find out that distance for each hour or each small interval of time remains same, then such speed is called uniform speed. Okay, now how would we define uniform velocity? How would it differ from uniform speed? That is what that is what is important to understand. I am going to use the same figure only. Now in case of uniform velocity, one more condition would add up, that is the object should travel from some point and reach to some other point, but in a straight line. Because as soon as the object will change its direction, let us say point, like here it is changing at point B, velocity is said to be changed, then it can't be uniform. You can say that something is uniform only when it remains constant. So other name for uniform speed is constant speed, and other name for uniform velocity is constant velocity. So you really can't change the direction also, because direction also plays the critical role, as I just said, in defining the velocity. So suppose the object is traveling on a straight line AB, and for each small interval of time, let us say 1 hour, or let us say 1 second, second, third second, fourth second, fifth second, sixth second, 7 second, you are able to get the distances y here, y here, y here, and so on. So if you are getting for each second, if the object covers y distance, then it is called y distance in a straight line, then it is said to be uniform velocity. So that's the prime difference between uniform speed and uniform velocity. Now next topic is average speed. Average speed. Suppose you are traveling some 100 kilometer distance. You already traveled some 100 kilometer distance, and you took 4 hours to do that. Then average speed, or you can write it like less than greater than v. This is how we represent average. Average of v is equal to total distance traveled, that is 100, upon total time taken, that is 4, that is 25 kilometer per hour. So this is your average speed. Now what is the difference between the normal speed that we were just talking about when we started the session, and what was the difference between average speed? Now it is not necessary that throughout the 100 kilometer distance your speed would have been constant at 25. At some point of time, let us say when you just started your car, it can be simply 10 kilometer per hour, so your speed dial would show 10 kilometer per hour. Then when you were traveling on highway, it can reach up to say 200 kilometer per hour. Well, one should not drive this fast, it's really not safe, but anyways, just for the sake of example, at some point it can be 50 kilometer per hour, 50 kilometer per hour, and so on. But when you just take the average of it over the entire time period, it turns out to be 25 kilometer per hour. So that is what we say average speed. Now average velocity. It would be just same as average speed, but technically I think average velocity is concept that can't be explained properly, because speed can be taken as average, because in speed direction is not playing any role, but in case of velocity direction would also play some role. So technically it is difficult to define average velocity too precisely. So you can go with the same concept that I just discussed for the average speed. So it would be similar to average speed, because you see, like I start traveling from my house to my friend's house, obviously directions are going to change at each and every point, so it is difficult to define average velocity. So right now we discussed about speed, then uniform speed and average speed, and velocity, uniform velocity and average velocity. In next video I'm going to talk about accelerations. So keep watching and thank you.